Okay, now this is section 3.4, so it's motion in space, and we're going to learn about the unit normal and how to find the tangent and the normal of curves. And I think we normally don't cover torsion in a binormal vector, so I don't think I actually gave you problems on that. I hope I didn't, because we don't normally cover it. Okay. All right, definition. At a point where the curvature is not equal to 0, okay, we can talk about the principal unit normal vector for a curve in the plane is capital N, and it is 1 over kappa dt ds. Okay. Now, I like to think of this as something much easier. So kappa, we already know, is the length of dt ds. All right, which my way of, I'll give you my way of remembering everything at the end so you can see how life can be so simple. Okay. So N is dt ds over kappa, which is the length of dt ds. Now dt ds is dt 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 ds. So this is dt times dt ds. And this is the length of that. And dt times, and this is times the absolute value of dt ds. So this just turns out to be dt dt divided by the length of dt dt. Okay, so these are the easier definitions. Okay. R of T is F of Ti plus G of Tj plus H of Tk. Okay. Then R prime of T is F prime of Ti plus G prime of Tj plus H prime of Tk. New V of T is simply R prime of T. Okay. New is simply the length of V of T, which is the same as the length of R prime of T. T of T is V of T over the length of V of T. It is also the length of R prime of T over, no, it is not. It is R prime of T over the length of R prime of T. The curvature is the length of T prime of T divided by the length of V of T. That is right. The curvature is a number. Okay, and then the unit normal vector is to take the length of T prime of T, no, is to take T prime of T and divide by the length. Okay, so there's all those the things that you need to know. All right, so here's an example. This is a very easy one. This is simple circular motion. So R of t is equal to cosine of 2t I plus the sine of 2tj. Okay. R prime of t is what? What's R prime of t? Hello.
Don't you pull the 2 in front of the cosine,
Yep.
and then wouldn't it be negative sign?
Okay. So you have -2, the cosine. Nope. -2, the sine,
Of 2t
2t I
plus
plus
2 cosine 2t
j.
j.
Okay. So now what is the length of R prime of t? What is that?
That's the one from yesterday, right?
Yeah, you just take the
Integral.
no integral. We're just taking the length. So the length is each piece squared. So you would get
Oh yeah, that's from last
-2
time too.
sine 2t
Plus
plus 2 cosine squared 2t. Okay, I can pull out the 2. Oh, that's not what I meant to do. That's what I meant to do. So I'm going to get 4 sine squared of 2t plus cosine squared of 2t. And that's just the square root of 4, which is 2. So R prime of t is 2. Okay. So what is the unit tangent? Anaya, how do you compute the unit tangent?
Oh, sorry. I was trying not to take you off mute. So how do you compute the what tangent?
The unit tangent.
And can you show that one more time?
So we're going to take R of t,
Oh,
R
and then
prime of
put it
t,
over the
and then
length.
divide by its length. So R prime of t is -2 sine 2t I plus 2 cosine 2tj, the whole thing over 2. So therefore t
Well, that one worked out perfectly.
Yes, honey, some of them are beautiful. T of t turns out to just be -2. Nope, the twos are gone. Negative sine of 2ti plus the cosine of 2tj. Okay, so now we need to find the derivative of that thing. So now the derivative of that thing is what?
Cosine 2t.
It's still negative.
Oh yeah, because it's a negative. Yeah. Plus, well, minus negative sine 2t. Yeah.
Okay, so now in order to find kappa,
See.
you need kappa. You got to find t prime over t divided by the length, which is v of t or r prime of t. So now did we find that? Yes, we did. So t prime of t is -2 cosine of 2t minus 2 sine. Whoa, 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 whoa. I'm doing the bad. Lord, child, I never forget teaching calculus 3 and none of the students could remember to put in I's, J's, and K's. It was a horrible semester. I minus 2 the sine of 2t j, and then I'm dividing by the length of v, which I think that was 2. So I'm dividing by 2 again. So therefore, t prime t divided by the length of v simply comes out to be negative cosine of 2ti minus the sine of 2tj. And kappa is the length of that thing.
Wait, why did you get rid of the twos?
Because I
You divided them.
I divided by 2 here.
Oh, okay. I just peeped. It was nothing at the bottom anymore.
Okay. So kappa then is the length of this thing. So that is minus cosine 2t squared plus a negative sine of 2t squared. And that's just 1. And then n says find the length of t prime of t. So the length of t prime of t is also 1. So therefore the normal is t prime of t over the length of t prime of t, which is 1. So that is just minus the cosine of 2ti minus the sine of 2tj. That's the normal. And you can show that the normal dot the tangent is 0. Something wrong.
Wait, how is it 0?
That's what I just said. Something's wrong. Because the tangent's wrong. The tangent's wrong. Oh, no, it isn't. There it is. Yeah, remember the normal, so here's the curve. The curve looks like that. The tangent is coming off like this. And the normal is coming out like this. So this is N, and this is T. They're perpendicular to each other. So when you find a unit normal, it's perpendicular to the tangent. Okay, one more example. Given this R of T, find T, N, and kappa. R of T is A cosine Ti plus A sine Tj. I think that's, yep. Plus BTK. This is the helix that goes around in a circle but lifts up as it's going. Okay, so they tell us A and B are positive or 0, and A, they're not both 0 at the same time. Okay, so we want to find T, N, kappa. You actually find kappa before you find N, but it's okay. All right, so we do R prime of T is minus A sine T I plus A cosine T J plus B K. So the length of R prime of T is the square root of A squared sine squared T plus B squared, nope, plus A squared cosine squared T plus B squared. And that simply comes out to be the square root of A squared plus B squared. Hence why they both can't be 0, be dead. So therefore T, just the length of R prime of, is R prime of T over its length. So I'm going to take 1 over square root of A squared plus B squared. And then I'm going to multiply by the vector itself, which is minus A sine of Ti plus A cosine of Tj plus Bk. Okay, nice and simple. All right, so now we need kappa And kappa is the length of T prime of T over R prime of T. Okay. So the length of T prime let's just find dt. Let's just find. So we need T prime. So T prime of T is 1 over the square root of a squared plus b squared. And then I have to take the derivative of what I have. So that's minus a cosine of ti plus, nope, minus a, the sine of tj. And the derivative of b is gone. So I just get that. So therefore kappa, so now I need to find T prime of T over the absolute value of R prime of T. So the absolute value of R prime of T is that 1 over the square root. So I'm going to get 1 over the square root so I get this 1 over the square root and then I have this minus a cosine ti minus a sine tj. And then I have to divide by the 1 over square root again. Okay. So now I get T prime, the length, T prime of T over the length of R prime of T dt, no dt, is equal to 1 over a squared plus b squared times this, which is minus a cosine of ti plus, nope, minus a sine tj. And kappa is the length of that. So kappa is going to be the length of that. Well, the length of that well, this is a squared cosine squared t plus a squared sine squared t over the square root. No square root, a squared plus b squared. So this just turns out to be a over a squared plus b squared. So that says to me that, excuse me, the more it unwinds, the less curvature it has. So the bigger B gets and it jumps up in the air, the less curvature it has. Has more curvature for small b. Okay, and we still need to find n. So n is t prime of t over the length of t prime of t. Hi, Juan.
Hello.
How can I help you? I'm in the middle of my class.
You're in middle class?
I'm in the middle of Calc 3, yeah.
Okay. Oh, sorry.
No problem.
Thought you had class. What's it called? Office hours, right?
Hours. No, not right now.
Okay. Thank you. Bye bye.
Mhm. Okay, so where's T? Okay, so what I need to do when I'm doing this is I need to circle stuff. So I found T. So let's go back for my brain and let's square off what T is. Okay, found T. Found kappa. Okay, so now I need to find T prime. I think I found T prime. Here is T prime. So that's T prime. Okay, so the length of T prime so the length of T prime I'm going to get a squared base a squared square root. So I'm just going to get a over the square root of a squared plus b squared. So therefore the normal n is going to be t divided by the length of t prime. So when I take the divide, I'm going to get this thing, which is t prime, and when I divide by that, I'm going to multiply by its reciprocal. So I'm going to get a squared plus b squared up here. And I'm going to get a down there. So when all is said and done, the normal just turns out to be negative cosine t I minus the sine of t j. And again, if you date n and dot it with t, wherever t is, that's t prime, there's t, you will get 0. Okay. We are actually a little ahead. Yeah, we're a little ahead, finally. We're not behind. We were so far behind, now we're ahead. Let me see if there anything, let me just take a peek at the syllabus and make sure I am covering everything. Okay. I'm gonna pause for a quick sec. Okay, so that's the end of this problem. I want to define for you the radius of curvature. We call that rho. And it is 1 over kappa. And so the way you think about the radius of curvature is whatever the curvature is, you can draw. So let's say, here's my curve. So at this point, I can find the radius of curvature. So once I find, so if I knew what this was, this is R of t equal to some x at ti plus y of tj plus z of tk. And I find that, then the radius of curvature, and this is the circle, and I got to get this right. that has the perfect radius that fits inside. I think, yeah. So at this point right here, that would be the radius of curvature. Because I think, let me see if I did that right. Try to make it. There we go. That, now we got it. Okay. So at this point right here, the radius of this circle okay. So if you took and you were to find kappa, then this R, this rho, the radius, is 1 over kappa. So now if you remember the kappa, the curvature of a straight line is 0. So you would expect that the radius of the circle that would be up against the straight line is infinity. There's just an infinite circle. You wouldn't have anything. What was the other one we did? Yes, we did a circle and we said the radius, we said for the circle, the curvature. So if you recall that was the other one. Recall. We had R of t equal to a cosine of ti plus a sine tj. And we showed that kappa equaled 1 over a. Well, its radius of curvature would be 1 over kappa, which would be a, and a is the radius of the circle. So that works out beautifully. Okay, I want to go back, since we have some time, to do some differential equations. And actually, I want these differential equation notes to go under the calculus here. Okay. Okay, so for the differential equation, let's just, so a particle has an acceleration vector a of t equal to negative 32k. Its initial position these are its initial conditions. R of 0 is equal to 100k. And V of 0 is equal to 8i plus 8j. Find the position vector. Okay. So we start off with the acceleration, and we know the acceleration is the derivative of the velocity vector. So if I integrate the acceleration, I get velocity. So v of t is the integral of a of t dt. So when I integrate, I'm going to get a constant I plus another constant j plus, oh, let me do this right. Let me write this out. Yeah. This is the integral of negative 32 k dt. Okay, so therefore v of t turns out to be c1. So I get a constant for the I component plus c2 for the j component, and I get minus 32t k, 32t plus a constant. Okay, are you with me? Anaya,
Yes, I can hear you.
do you know what I'm doing?
No,
No?
no. I heard constant.
Okay, so when you integrate, so we're starting with the acceleration, which is the second derivative. So we got to keep integrating till we go back to get r.
Oh, yeah. So we learned that in physics.
Yes, so we started with the velocity vector. I actually showed you this too in this section, that you start with the velocity, with the position, you get velocity. You differentiate velocity, you get acceleration. Going backwards, you have to add constants of integration for each I, j, and k position. So since there's nothing I, it could have been C1I, and I differentiated it and got 0. So I need C1I, I need a C2J, and then the 32K integrates back to a negative 32T plus a constant. So now I know V at 0, though, is equal to 8I plus 8J. So that implies that C1 has to equal 8. C2 has to equal 8. And negative 32 times 0 plus C3 has to equal 0. So C3 has to be 0. So now I know V of t is equal to 8I plus 8J plus a negative 32T K. And now I integrate again to find R of t. So R of t is the integral of V of t dt. So that's the integral of 8I plus 8J minus 32TK. So therefore R of t turns out to be 8t plus a constant C1I plus 8t plus another constant C2J. And then I'm going to end up with minus 16 t squared plus a constant k. All right, now R of 0 is 100k. Okay, so that says 8t plus 8 times 0, 8 times 0 plus C1 and 8 times 0 plus C2 is also 0. And negative 16 times 0 plus C3 is equal to 100. So C3 is equal to 100. So therefore, we're done now. R of t is equal to 8ti plus 8tj plus minus plus 100 minus 16t squared. Okay. Yep, that would be it. Okay. One more. So in this one, I'm going to give you R double prime at t is equal to the sine of ti minus the cosine of tj plus 4 times the sine of t, the cosine of tk. And then I give you R of 0 is equal to I minus k, and V of 0 is equal to I. Okay. All right, so to make my life easy, I'm going to change this to R double prime at t is the sine of t I minus the cosine of t j plus 2 times the sine of 2t. Okay, that is much easier to integrate. Okay, so therefore R prime of t is integrate sine is minus cosine of t plus C1I minus plus a negative sine of t plus C2j plus a negative cosine of 2t. Okay. Okay, so I take derivative of that, I get that. I take the derivative of that. Derivative sine, I get minus cosine. And then derivative of negative cosine, bring down, yep. So R at 0 now is equal to I plus K. So that implies negative cosine of 0 plus C1 has to equal 1. So the cosine of 0 is 1. So I get negative 1 plus C1 is equal to 1. So I get C1 is equal to 2. Okay. The J, so negative sine of 0 plus C2 has to be 0. So C2 is 0. And then negative cosine of 2 times 0. Oh, I forgot a constant. Plus C3. Okay. Plus C3 is equal to 1. So that says negative 1 plus C3 is equal to 1. So C3 is also equal to 2. So now I get R prime of T is equal to 2 minus the cosine of T I minus the sine of T J plus 2 minus the cosine of 2T. Okay. We got to integrate one more time. So therefore V of T, nope. R of T is what I'm trying to get to. R of T, I'm going to get 2T minus the sine of T plus C1 I. And then I'm going to integrate this and I'm going to get cosine T plus C2 J. And I'm going to integrate this and get 2T minus 1/2 the sine of 2T plus a third constant J. And I think I just did this wrong. I knew it. I wasn't supposed to use R here. I was supposed to use R prime. And R prime is V of 0. So this is R prime. It's just supposed to be I. So this is wrong. And this is supposed to be 0. Because there's no K term. C3 is 1. So that should just be T. Okay. So now R of T, R of 0 was I plus J. I plus k, wasn't it? I minus k. Wow, I really had that all botched up. It's I minus k, not even r plus k, it's r minus k. Okay, so that says 2 times 0 minus the sine of 0 plus C1 has to be 1. So C1 is 1. And this says the cosine of 0 plus C2 has to be 0. So C2 has to be -1. And then we get 0 minus 1/2 the sine of 0 plus C3 has to be -1. So C3 is -1. So if in my exhaustion and haste, because I've been doing this nonstop since God, this morning. I think this is right, but I would love to check it. 2t minus the sine of t plus 1 I plus cosine t minus 1 j plus t minus 1/2 the sine of 2t minus 1 k. I would love to check that. So let's check it later and see if that works.